So let's summarize and highlight what is unique and special at Elproma synchronization product. There are several advantages of Elproma comparing to competitive product. We can split them defining the value-add functionality into the two groups, the one related to antenna and the one related to time server itself. Let's focus on the antenna first. The Elproma antenna is a very special one. It is called the smart antenna. It is smart because it is including the built-in GNSS receiver and additional electronics supporting communication down to time server. The smart antenna can be equipped with various of replaceable GNSS receiver boards, each equipped with a different chipset. Each chipset comes from a different vendor. The Industry 4.0 is requiring well understanding of geopolitics. The world's biggest economies of China, United States of America, European Union, Russia and India prefers to exclusively use their own state satellite system for Industry 4.0 synchronization. At the Industry 4.0, the rules are short, constant and clear. The US economy needs to be dependent exclusively on a GPS only. The China economy will prefer dependency on China Beidou. Russian economy will accept dependence on GLONASS. India will focus on its new satellite system called IRNSS. Finally, the European Union will follow the time supported from Galileo satellite system. All other countries need to make a wise decision which of existing GNSS systems they want to be dependent on. Here probably the best choice will mostly point the full GNSS constellation. Now let's talk a little bit about replaceable GNSS receivers the NTS-smart-antenna can be equipped with. Elproma offers only the best approved GNSS receivers coming from world's most famous vendors including the Swiss-made u-blox, US Trimble, Japanese Furuno, European Septentrio, Russian NVS. But our portfolio carries much more receivers to select. Elproma customers can choose suitable GNSS chipset following the price criteria or a frequency criteria beginning from single band L1 frequency via dual L1, L2 or L1, L5 frequencies or even up to triple band L1, L2, L5 GNSS receivers. Of course, the single frequency L1 band receivers are most inexpensive one and they mostly are limited to very standard accuracy of stability of synchronization. The dual and triple frequency receivers improve robustness of synchronization, especially if the weather conditions are not good, but unfortunately they are more expensive too. Setting customer strategy is important when deploying synchronization at critical infrastructure or at large enterprises. Here, Elproma experts are always ready to assist giving right professional advices. The replaceable GNSS receiver modules are also very helpful when finding the unexpected firmware bugs inside the receiver. Normally this takes weeks or even months before a new firmware patch, the one covering the bug, will be released by chip provider. But here a simple replacing of GNSS module to another one, the one that bases on a different chipset, seems to be fast and very reliable plan B. Today, each of time server manufacturers still needs to consider a risk of instability related to numeric overflows inside the GNSS chips, especially when supporting the UTC leap second or handling problems like GPS weak number rollover, but also the errors related to algorithms when switching between specific satellite constellation GPS, Galileo, Beidou or GLONASS. Here, a locally done replacement of GNSS module at NTS-smart-antenna plays the important role to ensure continuum of operation at customer premise. Here our competitor fails, and they need to organize a service call. After months of waiting, the lucky customers are getting the new firmware patch to download. Unlucky customers needs to send back to factory the competitive time server product. The NTS-smart-antenna also improves stability and robustness. One of the unique functionalities is the possibility of simultaneous use two NTS-smart antennas connected to a single Elproma time server. It enables a real physical redundancy of GNSS receivers, but it also lets use a custom configuration where each of two receivers is focused on the different satellite system. Let's consider the first antenna to be configured to receive the GPS only and the second one to GLONASS. Does it make sense to you? Even the enterprise can be obligated by the law to follow, let's say, the GPS only. In some cases, it makes sense to trace the GLONASS and other satellite systems too. Tracing GLONASS does not necessarily mean you have to use it as a reference for synchronization, but it is still useful to know or compare both GPS and GLONASS, each coming from a different receiver, each exclusively set to operate with GPS or GLONASS. Such duality and redundancy ensure everything is stable and there is a minimum risk of time manipulations, including satellite spoofing or a delay McCuning attack. Here the GPS and GLONASS are only the examples, and therefore we highlight that any of them can be replaced in a real application by Beidou, IRNSS or Galileo. When considering the cybersecurity, it is important to highlight that Elproma standard product already includes the basic jamming and spoofing protection. Using two redundant smart antennas located a couple of 100 meters from each other provides the geographical risk diversification. If the one NTS-smart antenna is spoofed or jammed, the second can survive, keeping a full access to original satellite radio signals. But the standard Elproma smart antenna can be also equipped with the GNSS receivers that automatically recognize false, not original or reflected satellite information. Once the NTS smart antenna detects jamming or spoofing attack, it sends a special alarm message down to Elproma time server. Such alarm enables a holdover operation of time server that automatically switch to internal high-performance oscillator clocks. When operating in holdover oscillator mode, the time server is not using NTS smart antenna. Once the jamming or spoofing attack is ended, the end of attack message is sent down to time server to recover normal GNSS operation. The NTS smart antenna can be also equipped with advanced active anti-jamming and anti-spoofing filters. The active filters are automatically recognizing source of fake signals and they do filter them, staying transparent to original satellite signals. Elproma smart antenna can be also equipped with the multipath mitigation subsystem. It recognizes reflected from building satellite signals and refusing delayed phantom data from it. Finally, the smart antenna is also including auto-sensing and adopting auto-gain system. It let operate Elproma product in tough environments where there are bad weather conditions and electromagnetic interferences. The signal conversion to electric serial communication makes Elproma smart antenna easy to maintain during installation. The maximum connectivity length is up to 1 kilometer and solution is not requiring additional signal amplifiers. Cables can be cut or extended using standard Ethernet unshielded twisted pair category 5 or above cable. Altogether, this makes Elproma smart antenna a very unique and robust synchronization component. Now let's take a look a little closer to Elproma time server device. It is so-called the grandmaster clock. In case of Elproma, the time server is independent on GNSS, the network appliance device. It is supporting any kind of existing synchronization protocols, time codes, and frequency standards, including NTP, the Network Time Protocol, PTP, the Precision Time Protocol, time codes as IRIC-B, DCF77, frequency standards like PPS, 10 MHz, and many more. The main time server job is to ensure a robust synchronization and high accuracy time domain operation, the one that is following UTC, TAI, local time, or any custom built arbitrary timescale. The Elproma time server can simultaneously take a reference time and frequency from two smart antennas or from any local atomic clock. In case of professional metrology, Elproma time server supports cesium atomic clocks, for example the one like 5071A, taking both frequency and UTC phase directly from the internal hardware of atomic clock. Such technology is not available from Elproma competitors. In case of taking UTC phase and frequency, the Elproma time server does not need GNSS receiver. Supervising multiple reference time sources at the same time, the Elproma servers can also generate simultaneously a multiple timecode signal outputs. It enables the new time conversion functionality between different standards. A very good example can be conversion from PTP input to IRIG-B output used by modern smart grids. The natural consequence of above is the slave functionality of Elproma time servers. The slave mode receives and retrieves the reference clock information from the Ethernet using NTP or PTP protocols, and it generates locally the DCF77, IRIG-B or any other timecode output. The true novelty of Elproma time servers are autonomous Ethernet network interface cards. Here, each network card behaves like an independent grandmaster clock. In fact, the network cards are independent grandmasters and they are 100% isolated from each other. Understanding the new concept of autonomous network interface cards, it is important to highlight that this concept was born in 2015 as the result of European Union Horizon 2020 Dimitra project. The idea was to propose the technical solution that can provide a high accuracy time domain operation supporting independent networks from one device only. So what is the autonomous operating network interface card then? It is a grandmaster clock with own private CPU, memory, firmware and FPGA supporting the hardware timestamping for PTP and all related profiles. There is no internal TCP/IP communication between the network interface cards inside network appliance. The mainboard is only taking care for time domain control and all equipped inside cards. This is achieved by distributing internally the reference time and frequency and using the analog synchronization signals like PPS and time of the day. The hardware isolation and private resources for each network interface cards ensure the top synchronization performance for each separated network. It also assures best cybersecurity. Imagine the hacker gets control on the network interface number 1. Because there is no internal IP communication, he cannot move or disturb the synchronization of networks number 2, 3, 4, and so forth. Such architectures is resistant for random traffics and DDoS attacks too. The private PTP stack per each network interface card enables different PTP profiles on the different network cards. This is very unique functionality available from Elproma only, and it lets serve telecom and smart grids simultaneously from a single device. The last but not least is the holdover protection. The Elproma network time server device can be equipped with the various of high performance oscillators, including OCXO and Rubidium 1. The Elproma product can appoint any target application of Industry 4.0 market. We offer network appliances devices in customized configuration. The modularity of our product makes Elproma's solution flexible and perfectly suitable to any industry and to any level of architecture of any industry deployment as a part of cloud infrastructure, datacom and data centers, financial market, distributed smart grids, telecom, especially 5G. We are experts in timing, especially its traceability and reporting. Our company is expert in ensuring large-scale, country-size, time-domain operation dedicated for critical infrastructure of energy, telco, and finance. There is no business too small or too large for us. Our portfolio of product includes all kinds of grandmaster clocks, time servers, and time slave components. Elproma offers the embedded grandmasters, product that customers can include as a part of their own hardware solution. This can be neither the master sending time to Ethernet network or a slave receiving time from remote time server and setting local clock of Industry 4.0 sensor or any device. Using our embedded slave component, the customers save their time and money by getting ready operational solution that can be easily deployed inside any hardware. Our product portfolio also includes the smallest time server of the world, the NTS Pico. It is a time server dedicated for Industry 4.0 local management process support. This server is in size of pocket of cigarettes, but it is very powerful master and slave time server device that supports hardware timestamping for PTP and NTP protocols. Furthermore, NTS Pico is equipped with real-time clock with the battery backup. It ensures high accuracy time when NTS Pico is switched off. It's also ensuring ultra-fast start and ready clock operation immediately after power on. The NTS Pico is using UTC, atomic timescale, or the arbitrary timescale that can begin counting from zero. This makes NTS Pico perfect solution dedicated for automotive market, especially autonomous driven vehicles or any other Industry 4.0 and TSN time-sensitive networking related device. There is a special group of servers marked with the brand name Elproma SafeTime. They are all cybersecurity Rack 19 mount network synchronization appliances. Here the choice is between well-known free models NTS 3000, NTS 4000 and NTS 5000. They can support any IT-related industry including public administration. Grouping the SafeTime servers, you can create a time distribution systems. Such systems ensure time and frequency domain independent on GNSS. They simply generate and carry on own private corporation UTC timescale. The timescale distribution systems are used to disseminate accurate UTC over large networks, for example cloud or data center infrastructures. Such time dissemination systems are very useful for industry where properties of time traceability is important. Here, a new chapter of synchronization business is just beginning, creating a solutions and services recognized under name Time as a Service and Traceable Time as a Service. Such new services are more and more popular these days, and it is becoming to be a part of state-of-the-art cloud age computing. This is the last slide of this presentation. It shows a very little and partial list of customers who put a trust on Elproma product, choosing our time server last years. Synchronization is not a simple topic, and it is requiring knowledge and high skills. Elproma puts a lot of attention and effort to keep our product and services state-of-the-art. We would like to be a leader in Industry 4.0 and time-sensitive networking synchronization. If you are already the customer of Elproma, we would like to thank you very much for all these 30 years we have spent together in business. If you are new to market, we would like to invite you to join Elproma ecosystem. Let's work together on new projects and business development. There is no customer too small or project too big for Elproma, and we would like to kindly invite you for that. Let's join forces together. Let's do business together. Thank you.